If I told you that the fastest growing part of the space industry right now has almost nothing to do with rocket science and everything to do with what exact same skill you are already using in the cloud engineering role today, would you believe me? Maybe yes, and you should, because it's true. And by the end of this video, you're going to understand exactly why. We're talking about Kubernetes, we'll talk about CI/CD pipeline, observability, FinOps, the stuff you already know how to do. Just pointed at satellites instead of servers. This is Cloud to Space Transition Protocol, a step-by-step guide for taking cloud engineering skills which you have and migrating them to what's required for the space industry. No rocket science degree required here. I'm going to walk you through exactly how the industry got here, how to map your cloud skills and your technical skills, and I'm even going to give you a 90-day plan to actually execute this. I actively talk about the developments in the space industry, including the nuances of the space technology. So follow me on my YouTube video as well as my Instagram handle, which goes by Nuggets by PC. So let's deep dive into details of this cloud workshop. Here's the thing nobody outside the industry really talks about. Space just had its own cloud movement, and it happened because of the word constellations. For decades, satellite ground stations looked like this is a single rigid server stack, one dish, one building, and one point of failure. It worked fine when you had a handful of satellites talking to each other occasionally or to the ground station, limited processing capability, physical constraints, and when things got busy, bottlenecks, heavy data ingestion piled up. Overload, for example, throughput bottleneck. Picture a single loading dock trying to handle every truck in the city at once. And then came companies like SpaceX, Planet Labs, and a dozen more starting launching not one satellite, not 10, but thousands of satellites. Interlinked satellites acting like edge nodes in a massive distributed network. And suddenly, that one rigid track couldn't keep up. We're talking about terabytes of imagery per day coming from per satellite. Multiply that by a constellation of thousands and legacy ground infrastructure, it just breaks the whole mammoth of the volume. So what replaced it? Sounds familiar? A fast multi-node cloud architecture. Parallel data injection through an API gateway, distributed processing, scalable storage, serverless compute, AI analysis at the edge. This is literally the same architecture pattern you would use to handle a viral traffic spike on a web application, for example. But this is just applied to a satellite downlinks instead of a website visitor. Just replace the things here. And here's the part that really matters for your career. This shift created an entirely new economic model called Ground Station as a Service, GSaaS. Instead of space companies building and owning their own physical ground station, massive capex was put in and they're renting antenna time from a cloud style provider. Capex is shifting to a variable cloud spend in this. Again, sound familiar to a cloud context. That's literally like an AWS pitch from 15 years ago, just aimed at satellite dishes instead of data centers. The industry didn't invent a new way of doing infrastructure. It adopted to the cloud, which is your skill. Okay, so if the space industry is now running on cloud native infrastructure, the first thing we need to do is step one. Map exactly your existing skills overlap with what they need. Think of this as more of a convergence engine. On one side, you've got terrestrial cloud skill. On the other side, there's a space infrastructure needs, and they line up almost one-to-one. Kubernetes and microservices that maps directly to ground segment orchestration, coordinating dozens of ground stations and services the same way you are coordinating containers and across a cluster. And edge compute, that's onboarding like inference and filtering, running trained models directly on the satellite to decide what data is even worth sending down. CD and infrastructure as code, that becomes flight critical deployment pipelines, same discipline just with way higher stakes because you just can't SSH into a satellite to fix a bad deploy. FinOps and cost modeling, that's ground station as a service, billing and antenna scheduling. Figuring out the most cost efficient way to book ground station time, which is basically cloud cost optimized with a different vendor list. And observability and SRE practices, directly transferring to telemetry, tracking and command health. TTNC for short, tracking, telemetry and command health. monitoring whether your spacecraft system are actually healthy in real time. So if you're sitting there thinking, I don't know anything about orbital mechanics, that is okay. You are not being asked to become a rocket scientist. You are being asked to point tools you already understand into a new type of infrastructure. It gets a little more technical, but stick with me because this part is generally one of the most important things to understand if you want to speak the same language as the space industry. Calibrating by orbital altitude, because not all the orbits are same, and the orbit the company operates in completely changes the cloud architecture they need. So there are three main altitude bands. First is GEO, the geostationary orbit sitting way out about 36,000 kilometers above the Earth. It's actually at the same speed, so it's like parked in the one area, and that's where you get a continuous uninterrupted contact. That is where you get continuous uninterrupted contact. It never goes out. Why does it matter to you? So why does it matter to you? Because altitude directly dictates the cloud architecture you need to build. For example, if you're working on a LEO, your architecture driver is elastic scale and burst tolerant ingestion. The data pattern is bursty, high volume, event driven. The skill that matters most here is auto scaling. The same instant you are using to handling an IoT fleet, for example. If you're working on MEO, the driver shifts to reliability, precision, and redundancy. Data patterns are steady, but they are latency sensitive. Corrections need to happen fast and consistently. Your key skills is multi-region redundancy with a hard focus on low latency. If you're working on GEO, it's all about continuity and legacy modernization, because a lot of GEO infrastructure has been running for decades and now getting a cloud native kind of a facelift. The data pattern is continuous streaming, and the key skill is storage lifecycle management and disaster recovery. So here's the takeaway. When you're prepping for a role like this, one of the smartest things is to figure out what is the orbital regime of the company you're actually operating in, and because it will tell you exactly what is going to be the guiding principle for your cloud architecture. It's a little more technical in terms of the space, but stick with me because this next part is genuinely one of the most important things you need to understand if you want to really speak the language of the space industry. Calibrate by orbit's altitude, because not all the orbits are same. And the orbit a company operates in completely changes how you define the cloud architecture for the target state. And the three main altitude bands. One is the geostationary orbit, very high, typically 36,000 above the Earth, and it's typically stationary relative to the Earth's speed. So it's always static at one point, looks like it's parked in one area. It gives you a continuous uninterrupted contact. The second is MEO, medium orbit, roughly 2,000 to 5,000 kilometers. These satellites are visible at hours at time, and they're critical for GPS navigation, etc. And then there is LEO, which is low Earth orbit. Now these are typically closest to the Earth, roughly 500 to 2,000 kilometers above the Earth, and they're very fast, really fast. And what you see is these are often used for people from any ground station for few minutes per pass, and there are thousands of them up there. So why does it matter for you? Because altitude directly dictates the guiding principle for your cloud architecture you're building. If you're working on LEO, for example, your architecture driver is elastic scale and burst driven tolerant, for example. The data pattern is bursty, high volume, event driven. That skill matters most here is auto scaling. Auto scaling from a cloud context, the same skill you have for handling an IoT fleet, for example, where spiking traffic is together at once. If you're working on a MEO, the driver shifts to reliability, precision, and redundancy. Data patterns are steady, but latency is very sensitive. You have to do the course correction very fast and consistently. Your key skill is multi-region redundancy with a hard focus on low latency. And you're working on a GEO, it's all about continuity and legacy modernization, because a lot of GEO infrastructure has been running for decades and is now getting a cloud native facelift. The data pattern is continuous streaming. The key skill is storage lifecycle management and disaster recovery. So here's the takeaway. When you're prepping for a role in this space, one of the smartest things you can do is figuring out which orbital regime that company actually operates in, because it tells you exactly which is your existing skill in the cloud, which is going to matter you the most. Now that you have understood the landscape of the space, the orbits, etc., it's time to map your specific role, your persona, onto the space in industry equivalent. So example, if you're working currently as a cloud solution architect, your natural landing spot is ground segment cloud architect. Designing multi-region architecture that connects ground station as a service providers into data pipelines. Same skill set, new domain. Let's say you are a site reliability engineer, SRE. You can become like a space systems SRE, owning uptime, observability, and error budgets. Except now that for ground station system and telemetry health instead of a web application. Let's say you are a DevOps or platform engineer. Then you're moving into a ground segment platform engineer, building CI/CD pipelines, but now with verification gates adopted for flight critical ground connect and control. Because when your deploy pipeline is pushing code that talks into something orbiting the earth at 17,000 miles an hour, moving fast and breaking things is normal, and it's not really the vibe anymore. So step 3, now that you understand the landscape, the orbits, etc., it's time to map your specific skills, your persona into the space industry equivalent. So let's say you're working on a cloud solution architect. Your natural landing spot is ground segment cloud architect, designing a multi-region architecture that connects ground station as a service providers into data pipeline. Same skill set, new domain. If you are into SRE, site reliability engineer, you become like a space SRE or space systems SRE, owning uptime, observability, and error budgets, except now for the ground systems and telemetry health instead of web applications. If you're into DevOps or platform engineer, you move into ground segment platform engineer, building CI/CD pipelines, but now with verification gates adopted for flight critical ground connect. Because when you're deploying pipeline and pushing code that talks to something which is moving across the earth at a very high speed, let's say 17,000 miles an hour, moving fast and breaking things is not really the vibe anymore. So let's say your background is more on data or product side. So there's also an equal path. Data engineers can become satellite data engineers, building burst tolerant ingestion pipelines for intermediate telemetry and raw payload data. Basically the same ingestion patterns you're using for IoT devices, that phone, home, occasionally just scaled up. If you are an MLOps or ML engineer, you can become like an Earth observation ML engineer, retraining classification models on satellite imagery and deploying them into generally constrained edge environments. This is edge machine learning with real constraints, limited power, limited compute, no easy way to patch things. Data platform product managers can become satellite data product managers, translating things like orbital revisit rates and processing latency into actual commercial analytics products that companies or consumers, enterprises pay for. Notice the pattern here. In every single case, the title changes, but the underlying fundamental discipline remains the same. You're not starting over, you're just translating. Now let's get really honest, because step 4 is where you figure out what actually transfers. Very honest. Step 4 is where you figure out what actually transfers, what needs adaptation, and what you generally have to learn from scratch. I want to set expectations here and not hype up things here. Everything transfers perfectly, because that's not true. Direct transfer is like no adoption is needed. You take as is your skill and map it. Like Kubernetes infrastructure as a code, CI/CD pipelines, observability stacks, IAM, encryption. You're doing this thing day in, day out. You can walk into a space company and say, I can start using my skills immediately. Now there are areas where you need some kind of adoption. The concepts can be transferred, but the execution changes. Path-based data ingestion, for example, because unlike a website that's always reachable, you are only getting a data window when the satellite is passing over the ground station. Let's say LEO satellite. Now, ground station as a service billing models, a different cost structure is there than a typical cloud billing model. Edge compute under real power constraints. Not let's sign up a bigger instance and we have we can live with that. No, we have a very limited fixed power budget, and it's not changing. TTNC, link security, protecting the actual command control center to the spacecraft, which carries very different stakes than securing a typical API. And then generally a new territory where you have to learn everything from scratch, start from basics, orbital mechanics, RF physics, and signal processing, radiation tolerant hardware design, and space situational awareness, tracking of other objects in orbit to avoid collision, for example. My honest takeaway is like you're not walking into a zero learning curve. There are things which you can look at and list again. Most of your foundational skills can be transferred. You're filling the gaps, not starting from scratch. Action plan, I want to slow down on one concept because there is one thing which you should take away as from this video. And that is a single biggest mental shift you need to make moving from a web scale cloud to a space scale cloud. In the web world, the reality is always on, steady state, continuous streaming. Your server is always reachable, your API is always listening. That's just the assumption baked into guiding principles. In space world, the assumption is completely wrong. This one especially. Satellites are offline for hours at a time, literally out of contact, and then when they pass over a ground station, they dump a massive queue of data in a burst that might only last for 5 minutes. 5 minutes, and then it's gone again until the next round comes in. So requirements flip entirely. You have to shift from a synchronous APIs request response to a highly elastic, burst tolerant, event driven ingestion queue that can absorb a fire hose of data in a tiny window that then sit quietly for hours. If you have ever built systems around message queuing, event driven architecture, or burst auto scaling for something like a flash sale or a viral spike where you get a lot of traffic, Thanksgiving Day, for example, you already have the instant for this. You just need to reframe it. Instead of planning for a traffic spike that might happen, you're planning for a traffic spike that actually happens on a very predictable schedule every single orbit. Step 5. This one is very tactical. Let's talk about your resume, because this is where a lot of people kind of get stuck or lost. You know you can transfer your skills. The problem is your resume. How do you message it? Think of this like a code difference. Same underlying achievement, different framing. Outline, built streaming data pipelines, processing 5 TB of data per day of clickstream data. For space, you have to rephrase it like, hey, I've built streaming data pipelines, processing 5 TB per day of high volume event data. Small change, but seems edtech. High volume event data is domain agnostic, and a space industry recruiter reading that doesn't immediately filter you out. Outline could be design multi-region cloud architecture serving 10 millions per daily active users. The new line should be like, hey, I designed multi-region architecture scaling distributed edge inputs across global processing nodes. Same architecture, same scale. Just description in terms of the mapping is directly onto what is needed for the satellite constellation is looking for. Distributed edge nodes feeding into global processing. The space industry needs your distributed scaling systems capability. Your job on the resume is very simple. Translate web traffic into edge node events. Same substance, different vocabulary, and vocabulary is what you have to get right to go past the first level of screening. Okay, let's talk about 90-day execution protocol. This is the part you have been waiting for. Step 6, the actual plan. 90 days broken into 30 days phases. Let's go through it. Day 1 through 30, orient yourself. First, identify your persona translation. Go back to step 3, figure out exactly which title you're targeting, which is title you're great at. Go and actually read ground station as a service provider documentation deeply. Companies like AWS Ground Station or Azure Orbital publish real technical docs, and reading them into is a free education. And third, pick a right orbital regime. You can pick LEO, MEO, GEO. Don't try to be generic. Pick a lane because it changes everything downstream by the orbit. Day 31 to 60, build. Enroll in a part-time orbital basics course. There are solid ones on a lot of portals, and that don't demand like a career pause kind of a thing. Start building a space-specific portfolio project. I can walk you through 3 concrete project ideas in a second and update your resume based on these terms using the coding different approach as we have seen with step 5 to 90. Apply. Target 10 to 15 roles within this industry which is having a high overlap. Not like a scatter shot, you put it across 100 applications. No, focus list. Prepare interview narratives that are specifically around your technical skills which can be transferred. Have a concrete stories ready, how you did it, and you can project your portfolio project, for example. That's the secret sauce. We're talking about the project portfolio. Because here's the truth. Nobody can prove that I can transfer my skill than a working project. You don't need a massive undertaking. Just pick one of these three. Let's take a scheduler. Build a basic satellite path scheduling algorithm using a public orbital API combined with cloud serverless function. This directly demonstrates you understand path windows and you can build around them. Second could be a pipeline. Create a data ingestion pipeline that downloads, processes, and catalogs open sources, Earth observation imagery. This proves you can handle exactly the kind of burst tolerant ingestion which will be coming from satellites. Third could be the architect. Design a multi-region cloud segment architecture diagram using a public ground station as a service cost models. This is lighter weight than other two, maybe easier one, but it proves that you can think at system level that matters the most for architect track roles. Before we wrap up, because this might be the most important mindset shift in this whole video. There's a position and there's a strong position you can walk into interview with. The weak position sounds like I'm an aerospace beginner asking for a chance. The strong position sounds like I'm a distributed systems expert bringing missing cloud scale to legacy operations. Completely different framing on how you're putting your messaging of your skill. And you can prove that strong position by asking sharp questions in the interview itself. Like, hey, what orbit does your constellation operate in and how does the shape of your cloud architecture defines based on that? Or what's the current split between aerospace native to cloud native engineers on this team? So questions like this can give some good signals. They say, okay, you understand the domain, you understand the orbital dynamics. You're not going to be having a spoon feeding mechanism as you onboard in that company. You are showing the fluency. Let's bring this all the way back together. Cloud is a new mission control. Your cloud engineering skills, Kubernetes, pipeline observability sit right at the center. They connect to the distributed satellites. They connect to ground station as a service infrastructure. And they connect to the data analytics products that entire space companies are building around this whole details, the satellites. Here's a line I want you to leave with. You do not need a rocket science degree to work in space. You need distributed systems discipline applied to orbiting edge devices. That's it. That's a whole shift. The space industry is now a cloud industry. The only question left is whether you're going to translate your skills or wait for someone else to do it. Someone else can say, I can learn this cloud and route to space roles, opportunities. If it was useful, subscribe to my YouTube channel. I am also active on Instagram by Nuggets by PC. Talk about space insights, your career opportunities, what's happening in the space world, what's going to happen as a prediction. So go and follow my handle.